Hi guys! In this lesson, I'll explain to you general basic information about integrated circuits. They are one of the indispensable circuit elements of electronics in many electronic devices that we use in our daily life. Integrated circuits have their origin in the invention of the transistor in 1947 by William B. Shockley and his team at the American Telephone and Telegraph Company's Bell Laboratories. Shockley's team found that, under the right circumstances, electrons would form a barrier at the surface of certain crystals, and they learned to control the flow of electricity through the crystal by manipulating this barrier. Controlling electron flow through a crystal allowed the team to create a device that could perform certain electrical operations, such as signal amplification, that were previously done by vacuum tubes. They named this device a transistor, from a combination of the words transfer and resistor. The study of methods of creating electronic devices using solid materials became known as solid-state electronics. Solid-state devices proved to be much sturdier, easier to work with, more reliable, much smaller, and less expensive than vacuum tubes. Using the same principles and materials, engineers soon learned to create other electrical components, such as resistors and capacitors. Now that electrical devices could be made so small, the largest part of a circuit was the awkward wiring between the devices. For integrated circuits, the abbreviation IC, which is the initials of the words integrated circuit, is used. Also referred to as a chip or a microchip. It is a group of electronic circuits placed on a metal plate designed with silicon, that is, silicon semiconductor materials. Within the integrated circuits, each electronic circuit element is smaller than the independent discrete circuits. In integrated circuits, it has been shrunk to the extent of containing millions of transistors and electronic circuit elements in the area of a fingernail. The width of each conductor row in a circuit has been reduced as far as technology allows. Integrated devices have a very important place in today's modern electronics industry with their small size, lightness, and ease of use. Integrated circuits are more advantageous than discrete circuits in terms of price and operating performance. Ready-to-assemble integrated circuits require less material than discrete circuits. Their performance is high. Because it has a small size and its elements are close to each other, the circuit components transfer the current quickly inside the IC. Thus, less power is consumed. Integrated circuits are found in almost all electronic devices today and have revolutionized the world of electronics. Computers, phones, cameras, and many other electronic devices created with integrated circuits at cheap prices are indispensable parts of our lives that we use today. Integrated circuits can be produced in THT type, or through-hole technology, to be soldered to punched cards, or in SMD, or surface mount device cases, to be soldered on circuit board. THT ICs can be easily used by mounting on a breadboard or soldering to a perforated plate and printed circuit board. SMD ICs, on the other hand, are much smaller because they are designed for use on circuit boards produced by machines. For example, on the left, there is the THT type of the PIC16F877A model microchip controller belonging to Microchip Company, while on the right, there is the SMD model IC of the same model belonging to the same company. Likewise, on the left, on the Arduino Uno development board, there is a THT type microcontroller of Atmel Company, while on the right, there is an SMD model IC of the same company. Now let's look at how the pins of the integrated circuits are numbered. When we hold it to read the text on the IC, there is a notch on the left side. Pin names are numbered starting from this notch. This is the integrated 18 pins we reviewed. This IC is a 16 pins IC. In this integration, when we hold it to read the text, there is a dot on the left. The pins are numbered from left to right. As you can see, this is also a 13 pins IC. Finally, let's take a look at this integration. In the same way, when we hold the name in such a way that we can read it properly, the pin names are numbered starting from the point on the left. It also has a total of 32 pins. Now let's look at what the internal structure of an integrated circuit is like. For example, let's look at how the internal structure of the 74LS08 is integrated. As you can see, this IC has a total of 14 pins. When we look at the internal structure, we see that there are 4 logic AND gates. This logic gate has 2 inputs and 1 output. If both inputs are logic 1, that is 5 volts, the output becomes logic 1, that is 5 volts. If any of the inputs is logic 0, the output is logic 0. When we go into a little more detail and look inside an AND gate, we can see that there is a circuit consisting of 2 such transistors and resistors inside this gate. The microprocessors in the computers we use today are the microchips produced with the highest technology. These processors, which are produced with today's technology, contain millions of transistors, each of which is approximately 14 nanometers in size. Instead of the modular structure of our computers, the microcontrollers we use in the development boards that are widely used today, all the necessary units such as the central processing unit, or CPU, memory, or RAM, and hard disk are gathered in a single integration. Microcontroller ICs are programmable. In this way, only one job will be done. These ICs are used in relatively simpler applications. The written program is saved in the microcontroller program memory and runs continuously when the IC is energized. Companies such as Atmel, PIC, Texas Instruments produce very different kinds of microcontroller ICs. With the development of technology, an entire computer could be reduced to a single integrated size instead of simple microcontrollers. Thus, complex structures such as CPU, RAM, and GPU, which can offer higher processing power just like our personal computers, are gathered in a single integrated circuit. For example, these chips are used in cards such as mobile phones, tablets, and Raspberry Pi. When the integrated circuits are to be used on the breadboard, they are inserted right in the middle. Thus, any of the pins can be used separately without short-circuiting. For example, here you see a simple circuit built on a breadboard with a 555 timer IC. Since ICs are very sensitive to static electricity, they should be repaired in accordance with electrostatic discharge or ESD techniques. When we touch it directly with our hands, they can deteriorate quickly due to the static electricity in our body. This electric discharge can cause damage to electrical tools and components, and, in some cases, actually cause equipment failures. The most frequently occurring damage caused by electrostatic discharge is when a person or tool that is electrically charged touches a grounded device which has a low resistance to static electricity, which in turn causes the sudden flow of electricity between the two objects. You can access the technical documents of all the ICs at alldatasheet.com. It is possible to access these documents by typing the name of the integrated circuit in the search section. The basic structure of the integrated circuits on the electronic cards is like this. I hope it was useful for you and you enjoyed it. Hope to see you in our next lesson. Goodbye.